there is a new drama going on. And the drama is that someone found out that the Express LRS is not secure. The deal is that based on some of the bulletin published last week, so that would give like more than a week actually from today, there is a problem with the Express LRS implementation that allows you quite easily to pretend that you are completely different transmitter. So that if you are close enough to other people that are using Express LRS, you can, just by listening to the transmission that's happening on the air between the transmitter and the receiver, you can kind of easily, actually up to one, you can get basically from the protocol 3/4 of the unique ID of the transmitter and just hack and brute force attack the remaining one. According to the bulletin and the article that you can read over here, this basically causes that you can hijack the radio link and you can steal or hijack the drone. There are a few things that we kind of have to understand. That first of all, the RC links are not secure by design. Almost no one really does the encryption over the link. Why? Because encryption is expensive. You have to figure out the protocol that handles encryption. You have to have much stronger of the MCU on the transmitter and the receiver so that they can handle the encryption over everything, like push the data left and right, do the proper key exchange and so on. So none of the links are really doing the encryption. I think the FreeSky Access has really the encrypted protocol, but this is, let's say, the exception. In every other case, we should not really use the word encryption or the security, because the radio links are not designed to solve this particular problem. Yes, they are using an element, the keys. There is a key that has to match from the transmitter and the receiver for everything to work, but this is, one more time, not an encryption and not something that was ever designed to be non-breakable. When building your own transmitter receiver, you have to basically cover two problems. Problem number one is that you do not want to use only one channel, only one frequency for the transmission, because if anything happens on this channel, then you will be jammed and you will have no connection. So the idea is to have a set of channels and just jump between channels for each and every packet. So packet number 1 is on the channel 5, packet number 2 on channel 7, packet number 3 will be on channel 57, whatever. There should be a pattern of jumping, and both the transmitter and the receiver should be using exactly the same pattern to know which channel is used right now, should be used right now, which channel will be used next, and so on and so on and so on. So after sending each packet, both transmitter and receiver retune themselves to next channel, the same channel, and so that we have the spread spectrum transmission over the air. So this is number 1. And number 2 is that the receiver should be listening only to the one transmitter, because it has to be able to understand which transmitter is transmitting and data from which transmitter the receiver should understand as directed to him. Because if not, then two people would not be basically able to fly, because if there will be a conflict on the channels and just two transmitters will try to transmit on the same channel, then the receiver would not know if it should read the data from transmitter number 1 or number 2. Both of those problems are solved pretty simple with the binding key. Because the binding key, and we will not go into the binding key too much, is just the seed, for example, for the random number generator, that can be used for both knowing which channel will be used next, because if you have the same unique identifier on both the transmitter and the receiver, and you initialize the pseudo-random number generator with the same seed, then the next value from the random pseudo-random generator will be the same. We know to which we should jump. And the second aspect is to how to compute the checksum. so that the unique identifier is just part of the payload for the checksum that is then attached to the payload. If we got some data, receiver got some data, adds the unique identifier, computes the checksum, checks if the checksum sent from the transmitter matches the one that I computed, and we have it. They do. That means that the message was sent for me, not for someone else. So two very important problems solved with the single solution, the binding key. And apparently what's happening with the Express LRS is that it's pretty simple to get the binding key just by listening to the transmissions between the transmitter and other receiver. So if you are close enough, what you can do, you can build some kind of the decoder of the Express LRS protocol, and in a minute or two you will just get the binding key that then you put into your transmitter and you start transmitting. And the receiver will not be able to differentiate if the signal comes from the original transmitter or your transmitter that you just, let's say, put there instead of something else. Theoretically, it is a problem. But practically, it's not a problem because this approach does not really allow you to hijack anything. The thing is that this hack does not allow you to cut off the original transmitter. You can only pretend that you are the original transmitter. And that means if your signal is not much stronger than the other signal, then you cannot really pretend from the transmitter that there is only one transmitter. What's gonna happen? What you can do is that two transmitter will try to transmit exactly the same different set of the data on the same time, on the same frequency with the correct checksum, so that the receiver will not be able to understand one of those. Sometimes it will get one, sometimes the other, sometimes none. In general, we can create a conflict on the bus, and the error is in the case the bus, and as the result, we can force the failsafe on the receiver. Is it a problem? Well, kinda yes. Is it the big problem? No, not really, because like I said, you cannot obtain in this way easily control over the craft. Yes, if you are like 5 meters from the drone and the original transmitter is 5 kilometers that way, then you have just much stronger signal and you can take over the control. But as long as the power levels are comparable, you are just unable to cut the second one off. And if you only want to, let's say, make the drone crash, you do not need this hack. You only have to start transmitting on the wide band with enough of the power, and the receiver will not be able to get anything from the data, and you will crash as well. So this problem in the practical means is not really a problem. You as the user that is using Express LRS only as the hobby, do not have to worry about this at all. The chance that it can be used against you and it will be used against you are rather non-existent, so just keep having fun as you had. If you would like to know more about the Express LRS, here's the link for you. In the meantime, I'm Paweł Spychalski. Thank you very much for watching and happy flying!